Thank you very much for the introduction, and thank you very much for the invitation. It's a pleasure to be here, and I'm really enjoying the meeting so far. It's really, really good. I'm going to talk about a very specific piece of work that we are doing at the moment. It's a new project for us. It's developing a specific climate change risk assessment for our cultural heritage sites that we manage on behalf of the Scottish Government. It's, as I say, a new piece of work. We've been doing this for less than 2 years, so I'm very pleased to present the results of where we are so far. I'll start off with a little bit of the context and the drivers for the work in terms of our political drivers and our climate drivers, and then describe the work itself in some detail. Okay. So you just click. Okay, I've got it, right. Our organisation, we are Historic Environment Scotland, are the Scottish Government's climate change agency, heritage agency. It feels like climate change agency at the moment. We directly manage 336 properties, cultural properties in the care of the state. We have a very large geographical spread throughout the country, including many remote Scottish islands. And unfavourable environments. We are also a large player in the tourist business. We're the biggest player in the tourist business industry in Scotland. Last year we welcomed over 4 million visitors to our sites. We also have a regulatory role in terms of overseeing consents on our 8,000 national scheduled monuments and 48,000 listed buildings. And we support the historic environment, the broader historic environment, local authorities, etc., through advice and standards and training in traditional skills and materials. We're also a large investor and giver of government grants as well. So in terms of climate change, we are strongly placed in order to influence our sector, and that is what our government is pushing us to do. The Scottish Government, under the Climate Change Scotland Act, is empowered to direct all public bodies in Scotland to undertake a series of climate change actions through the Public Bodies Climate Change Duties policy. And this charges major public bodies with tackling climate change under the 3 themes of mitigation, adaptation, and sustainability. So under mitigation, we have to contribute to the national emissions reduction targets directly and through our wider functions as well in our sectors. We have to undertake programs for adaptation and planning to increase resilience within our sectors and to build adaptation decisions into our planning and investments over future decades. And as well as the broader sustainability agenda, considering social, economic and environmental impacts of all our decisions. In 2014, our government published its Climate Change Adaptation Programme, its first Climate Change Adaptation Programme, a 5-year piece of work called Climate Ready Scotland. And my organisation has some specific objectives within that, namely to understand or increased understanding of the effects of climate change impacts on buildings, and we're undertaking that work through our research programs into the physical impact of changing weather patterns and looking at accelerated decay rates of materials and sites. Secondly, to increase knowledge, skills and tools, and in that piece of work we're developing a methodology for a climate change risk assessment for our own estate of properties, and developing a toolkit for the wider environment, and that's what I'll talk about later on. And lastly, to increase the resilience of buildings and the wider historic environment, largely through our dissemination of guidance and training and advice work. We have a climate change action plan, which is coming. We're just coming to the end of our first 5 years. It's very broad in terms of its aim because it has to capture the entire government agenda on climate change. So it varies through from reducing energy use and the carbon mitigation agenda through to broader sustainability issues, to developing and promoting sustainable tourism. And our wider influence. But relevant for this presentation is our theme on building resilience and preparing the historic environment for climate change, where we have specific actions to undertake a climate change risk assessment across our own estate, to evaluate which sites are most at threat, to develop strategies to manage those impacts, and to use that to develop a methodology to assess the impact of climate change on wider historic assets across Scotland. And alongside that, we are expected as a public body to act as an exemplar for addressing climate change in our sector. We understand fairly well anticipated change and climate change projections in Scotland. We are looking at, by 2050s, under a high emissions scenario, sea level rises of between 16 and 28 centimetres. We're looking at increased temperatures of between 2 and 3 degrees C in both summer and winter. And we're looking at decreased precipitation in the summer and increased precipitation of about 16% average in the winter. Quite similar numbers to what we were seeing this morning for Sweden. The other significant issue and similarity to what we saw this morning for here, I think, is the regionality of the changes. The fact that they're very seasonal in nature, so we will have drier summers and wetter winters, but specifically certain parts in the north and the west will be significantly wetter, and we've got drier. So most of our increased rainfall is associated with coastal areas and western areas in particular. So we've got a pretty good idea of the projected changes that we will expect. In summary, that's milder, wetter winters and autumns, warmer, drier summers, but with more intense rain periods, and winter storms, which will be more frequent and more severe, and a rising sea level. But what is really significant for us and in our work at the moment is the fact that we are already observing these changes, and we've got very good data to show us that since the 1960s, these changes have already begun to happen. So we have, I've just summarized a number of these here. Significant ones for us in our sector are we've got about 5 weeks longer growing season because of increased rainfall, increased precipitation, increased temperature. That has a significance that has an impact on the historic environment. Since the 1960s, we've seen a 1 degree rise in temperature. We've an average of 21% more rainfall, although in the winter, in the north and the west of Scotland, we are seeing numbers more like 70% more rainfall, 70% more rainfall. And our sea levels have risen between 3 to 4 millimeters, are rising 3 to 4 millimeters per year and accelerating. And one of the main issues for us is winter precipitation, and these maps show changes in precipitation, summer and winter, from the 1960s. And you can see very, very dramatic changes, particularly in the north and the west of Scotland, where in some areas we're getting almost a doubling, in some areas 100% more winter precipitation. So very, very severe impacts, particularly on our west coast. If anyone needs, we need these. So our climate change risk assessment project, our approach is based on the fact that many of our sites are located in locations that are highly vulnerable and susceptible to natural hazards. We know that climate change in the last 5 decades is already severely affecting our sites. We're seeing it on the ground in our day-to-day management. So our initial project was to undertake a scoping exercise, which is essentially an assessment of existing natural hazards at our sites. We undertook this as a desk-based GIS study. whereby we pull together a range of existing environmental data sets from our Environmental Protection Agency and the British Geological Survey, data sets that we considered relevant to the management of our sites and broader cultural heritage in Scotland. We used 6 natural hazard data sets for which we calculated risk. These are coastal erosion, ground instability, and 4 data sets on flooding, fluvial flooding, pluvial flooding, coastal flooding, and groundwater flooding. Critically, our assessment assumes that climate change will increase the rate of occurrence of these existing hazards. And that's a key thing for us, is that climate change will simply be an acceleration of these existing risks. But a big issue for us was we didn't have a starting point, we didn't have a baseline. So for us, this is a baseline exercise to screen our properties for existing environmental hazards. These are the environmental hazard data sets that we use. I won't go into these in any detail, but they're quite complicated. We worked, so slope instability is a good example of that, which combines geology, gradient, sources of water, drainage systems, and man-made land use and changes in land use. Some of these data sets are quite complex. We've worked closely with our environmental agencies and the Geological Survey to be sure that these are relevant to us and so that we can understand these. And that's taken quite a bit of effort and quite a lot of close collaboration between us and the other agencies to do that. Our methodology has been a desktop GIS exercise to undertake spatial analysis on ArcGIS, essentially overlaying our site boundary polygons with the various hazard maps that we've acquired. We run queries in GIS to generate a series of hazard profiles for each hazard for each site, and then each property for each hazard is allocated a likelihood score of 1 to 5, with 5 being most likely and 1 being least likely. So essentially, we end up with a series of likelihood maps, and here's 4 of the indicators for one of our sites in the north of Scotland. So you can clearly see coastal erosion. We've got highly susceptible areas up here. Coastal flooding, we've got some areas here that are 1 in 10 year likelihood of flooding, or 1 in 100 year likelihood of flooding. So we're left with a very practical set of site maps, which we can use, feed into our risk assessment, but equally are very useful on the ground for our site management. What we're aiming to do is to incorporate this exercise with our corporate risk register to get climate change onto our company's agenda and onto the government agenda. So on the right here is the risk descriptors for our corporate risk assessment. So this is standard stuff. This is standard risk assessment stuff. But this is what our board and directors work to. So we worked very hard to make sure that our risk ratings will comply with this and fit directly into this. So in order to do that, the critical thing to get these numbers is to get the multiplier right. Is our multiplier between the likelihood, which comes from our hazard assessment and our hazard maps, and the impact, so to generate a risk score. So the likelihood for the 6 data sets we split into 5 categories. Do not believe will ever happen, through to likely to occur. But the critical issue here is the impact. How do we measure the impact of each of those hazards on our historic environment? And that's the tricky bit. What we've done is frankly taken a fairly simplistic approach at this stage, because we want to push the data through, we want to get there and see if it's working for us. In order to assess impact, We've designed impact scores, which are assigned on the type of historic site that we have and the type of hazard in question. Our condition survey process for the management of our sites splits our historic sites into 6 categories, depending on their type and condition. So roofed monuments, occupied, roofed monuments, unoccupied, right through to field monuments and stones in fields. And what we've done is taken those 6 property types and scored them alongside the individual hazard in order to generate an impact score, so that the hazards of landslides and coastal erosion are so devastating and catastrophic that the impact remains the same, because it's a catastrophic impact, irrespective of the type of site. But in consultation with colleagues through our organization, we have ranked impact and changed the impact scoring for different sites, so that for our organization, at least, a roofed monument which is occupied is likely to contain valuable collections, historic collections, museum-type material, and is therefore more vulnerable to flooding, or will have more damage, more at risk from flooding, I should say, than standing stones in a field, than field monuments. Now, there's a lot of assumptions there, but we have had to make assumptions to get this process, to try this process out. So what that has done for us, our risk tables then, we ran 352 of our sites. We ran them straight through the process of likelihood times impact, and it turned out that 89% of our sites are exposed to unacceptable environmental factors, environmental risks. Now, when I told my director that, he nearly fell off his chair. And we made this public as well. But that, for us, is a starting point, and that reflects the fact that our sites are in vulnerable locations. They are vulnerable by nature of their age and their exposure to the environment. And that merely confirms the estate that we manage. But the key thing is, we manage it. We manage that estate. So that, for us, is our starting point. We term that the inherent risk. That is the inherent risk through environmental exposure that we as an organization have to manage. The key to that, now I don't expect you to read this, but it's just to show you the process. So these are each sites, each of the 6 hazards. It's hard for me to see here. And the inherent risk rating gives us this, takes us to here, with the multiplication of likelihood and impact. The key is the mitigants and controls that we, as an organization, through our management of our heritage, place to reduce risk. So that's what we do. So what was really crucial for us was to develop a set of criteria that would reduce the impact through our mitigants and controls, and to quantify that. And again, we had to make a lot of assumptions to do that, but that's been a really useful exercise. So what we're doing is factoring in our site operations, our maintenance and repair programs, the fact that sites are manned, are staffed or unstaffed, and if they're closed, open to the public, if they're seasonal, if there's someone there all the year. And all these have an influence on the risk that a particular hazard will present to a site. So effectively, what we're doing is modifying the impact for each hazard by our management of the site and multiplying that through with the likelihood to give us a residual risk. And when we do that, we come down to about 50% of our sites are still are exposed to environmental factors and hazards that are at high or very high risk. What we were able to do with those results is some analysis of those sites. So looking at which particular sites in a manageable way now, record very high hazards of very high levels of risk of one or more hazards. We can categorize our sites into different hazards, and we can at least start to manage the problem. We're able to present the data in a very useful way in terms of prioritizing sites, so we can create essentially a dashboard showing the different hazards for different sites in order to present the data within our organization. And what we have been able to do now in the last few months is actually influence the prioritization of works on sites and actually start to tackle some of these priorities. So I've got a couple examples just to finish with to show you some of the work we've been doing in the last few months, really. And this is a castle on the west coast of Scotland, Castle Sween, where we've had long-term issues of coastal erosion. It was flagged up through the risk assessment as ground instability and coastal erosion, both high risk. We have been losing masonry from this monument for a lot longer than I've been around, but it's becoming increasingly difficult to manage. And we are now using our risk assessment exercise to prioritize our funding and our work on site. So we've been undertaking rock stabilization works there in the last few months, essentially some engineering work to pin the rock, pin the bedrock, and reinforce the bedrock on which the castle stands. Another site where we've undertaken recent works is it's Blackness Castle, where we have a large historic harbour, a scheduled harbour, protected area. But in the south of that area, our risk assessment exercise showed us that we had susceptibility to coastal flooding and coastal erosion. On speaking with the staff who managed the site, they confirmed that this has been an issue for many years now, for a couple of decades, and was becoming increasingly difficult for them to manage in a reactive way. So we prioritized our investment at this site and undertook a significant phase of rebuilding part of the harbour wall. So what's been interesting is we've taken this desktop exercise, we've taken it out of our office, out of our headquarters, and we're beginning to talk to the guys on the ground where we've got these priority sites. And almost every time we do it, they say, "Oh yeah, we know about that. That's a problem we've got. We've had that problem for a couple of decades or a couple of years or even longer." And it's really confirming what is, for our point of view, purely a desktop data-driven exercise. We're beginning to ground truth that, and almost every single time it's confirming what we are saying. So we're pretty happy with the way it's going. And the last example is Fort George in the northeast coast of Scotland. I think I showed this one a bit earlier. So again, we've got issues of coastal erosion and potential breaching of the fortress walls and flooding of this area here. We've got extreme problems on the weather side, retreat of the existing ground we've lost from here completely. This site's under a lot of pressure. And over a number of years now, we've been undertaking not very pretty rock armour barrier work. This is a particularly difficult problem for us, but again, the exercise, the risk exercise has allowed us again to focus in on this area and say this site is a particular priority for us. It's early days for us. We feel like we're a newborn. The project's about 18 months old. It's just beginning to get on its feet and start to walk. What we need to do next is more ground truthing. We need to get out to the sites. We need to refine the exercise. We need to increase awareness amongst our staff so that the results are going to be more widely applied, mainstreaming that into the planning and the day-to-day maintenance. We are just beginning to produce site-specific climate change reports for sites where we're combining this assessment of existing environmental hazard with our climate change projection data and our Met Office data, and that's kind of the next stage is to enlarge that. The other thing we're aware of is that the work so far is simply based on our scheduled protected site boundaries, and we're going to expand the GIS to include a buffer zone because environmental threats are wider, and we could be facing hazards at sites which are originating outside the site. So, for example, we've got issues where we know of some properties that we have where the actual sites themselves are not showing any significant risk, but just outside our sites in terms of access roads, there are areas of ground instability and flooding which would prevent emergency vehicle access and cut our sites off effectively from all communications. So the work's just really beginning in terms of where we take it. Okay, that's me, and I was just going to put a little advert for our Adapt Northern Heritage project, which you've already heard about a couple of times this morning, which we're very excited about, and my colleague Karsten Herman can be contacted. He's sitting here today and tomorrow as well, so please contact him. We're very excited about this project and looking forward to working with quite a few of you in this room. So thank you very much.